Okay, geometry, section 4.1, classifying triangles. Okay, so I know your notes look a little bit different here, and they're just the organization of them looks a little bit different on yours at the start here, and then it'll get back to normal. But again, just draw the picture for for your example, and then your description. Just kind of talk about what I have underwritten underneath each of these. So a couple different ways in which we can classify triangles, and that's really the objective here today, is going to identify and classify triangles by the angle measures and by side measures. So two different ways to classify them, one by angles, one by sides. So this first one here is about classifying them by angles. So the first one is the acute triangle. So in your description, write this down here that it has 3 acute angles. There's 3 acute angles. And you might want to, in your example, draw the picture, and then just make sure that you have, like put this is 50 degrees, this is 60 degrees, and this is 70 degrees, just to show a triangle with 3 acute angles. The next one would be an equal angular triangle. So this one has 3 congruent acute angles. So they all have to be 60, and if that's the case, they would all have to be 60. So just make sure that they have the arc mark here and that they're 60 degrees for your equal angular triangle. So again, your description would be the words underneath the triangles here, and your example will be the picture. An obtuse triangle, it's going to have 1 obtuse angle. 1 obtuse angle will be your description. And so your picture, going to have to draw one that kind of has, you can draw this very similar to this, but this wide angle here is going to be 110 degrees right in here. Okay, so make sure it's something that's over 90 degrees. And then your right triangle is going to have exactly 1 right angle. Okay, so again, you've got the box here, so make sure your description has, your example has that in that angle right there. Okay, so that is the 4 ways in which we can classify them by their angles. And then by sides is the next one. So by sides, we're looking at equilateral, isosceles, and scalene. An equilateral triangle has all 3 sides are congruent. So make sure you show that with the dash mark. And then an isosceles triangle has at least 2 sides congruent. Okay, so that's tricky because it says at least 2 congruent sides, which means that it could have 3. So basically we're saying that all equilateral triangles or all isosceles triangles are not necessarily equilateral triangles, but all equilateral triangles would be isosceles triangles because they would have at least 2 sides congruent. And then you have a scalene triangle, which has no congruent sides at all. So you don't have any dash marks. You have different sides. So just kind of when you draw the pictures, try to show that either by hash marks or double hash marks that they have congruent sides. Okay, so again, this was showing you by sides here, and the earlier one was going by angles here. Okay, so a lot of different ways in which, a couple different ways to which we classify them, and then a lot of different examples there. Okay, parts of a triangle. So we've got a lot of different things to write down here. We talk about the different parts of a triangle. So the first one is the vertex or vertices. This is the points. Points where the sides intersect. So you're going to have your 3 sides of a triangle. Well, where every 2 of those sides intersect is going to be called a vertice. So in this triangle over here to the right, I'm just going to kind of draw in some vertices here. I'm just going to say A, B, and C. Those points would be your vertices of the triangle, where each of those lines meet. The hypotenuse, when we talk about the hypotenuse, that's really in when we talk about in right triangles. So it's only in a right triangle, and it's the longest side. Okay, so our example here to the right it is a right triangle because you can see the right angle symbol over at the vertex A. So the hypotenuse is going to be opposite the right angle. It's the longest side. So that's going to be over here is going to be your hypotenuse. Okay. And then we have legs. Well, in the case of we'll call it there's kind of two ways to look at this when we talk about legs. In a right triangle, let's do that one first. In a right triangle, the legs are the two sides that make up the right angle. They would make up the right angle together. Okay, so for instance, in your diagram over here, this would be one leg, and this would be the other leg, because together those two sides would meet at vertex A and form the right angle. But in an isosceles triangle, we would say the legs are the ones that are the two congruent sides. So in an isosceles triangle, these would be the two congruent sides. Okay, so I'm just going to draw a isosceles triangle here just to kind of down underneath here, and you can do that on your notes as well, just to draw one. That these two sides are equal, so those would be considered the leg of this triangle, okay, or the legs of this triangle. A vertex angle is in an isosceles triangle only, and that is where those two legs intersect. So in this case, in our example down here, you've got one leg, and we would say that this would be the vertex angle here. Okay? And finally, the base angles, again, are in an isosceles triangle, and those are going to be the angles where the legs and base intersect. Okay, so I don't think we talked about the base of a isosceles triangle, but it would be opposite the vertex angle. So if you've got the two legs, the other side would be your base, and therefore your base angles would be these two here. Okay? And they would have to be congruent because the legs would have to be equal. Okay? All right, so a lot of stuff there. Let's do some practice problems now. First, true or false? Give an example here. All isosceles triangles are equilateral. All isosceles triangles are equilateral. Well, that would be no. Okay, that's going to be a false answer there, because you could, when they ask for an example, you could basically, if you can come up with a counterexample, that would be an example of one. Okay, so you could have an isosceles triangle that's not equilateral would be a simple example. Say these two are equal. This is 5 centimeters, 5 centimeters, 8 centimeters. Okay, that would show it's an isosceles triangle that's not equilateral. Okay, the next one, all equilateral triangles are isosceles. We kind of talked about this earlier, and that is true. That is true because it has at least, remember, this has at least 2 congruent sides. So it could have 3 congruent sides. If it has 3 congruent sides, it has 2 congruent sides. So all equilateral triangles are isosceles. All right, the next one for us here is going to be to classify this triangle as acute, equal angular, obtuse, or right. And this one's not on your notes, but it's a really quick one. We know it's acute because it has all 3 60-degree angles. It's also, because they're all 360 degrees, it's also equal angular. It's not obtuse because it doesn't have a right angle, obtuse angle. It's not right because it does not have a 90-degree angle. So let's go right to the next one. This one is on your note sheet here. Classify the triangle as acute, equal, angular, obtuse, or right. Well, in this case, this would have to be an obtuse triangle because it has this one obtuse angle there. Okay, let's keep rolling. The next question. All right, this one says to classify triangles by sides. And so that means we're going to have to, right here, cross this out and say classify it by their sides. There's a little typo in there. Okay, so this triangular truss shown is modeled for steel construction. So it's a little architecture problem for you. Classify these triangles, JMN, JKO, and OLN by their sides. So if you have to measure it, get a ruler and measure it, but I'll just trace these and let you do this on your own. Remember, by sides, it's either going to be equilateral, isosceles, or scalene. So triangle JMN is this one here. Going to look at that one. Triangle JKO is going to be this one. And then you're going to look at triangle OLN, which is this one right here. So classify those by their sides. All right. Next one. Point Y is the midpoint of VX, and WY is 3 units. Classify it as either equilateral, isosceles, or scalene. So let's take a look at this one and see what we have. Just the given information here says WY is equal to 3.0 units. Okay, and we know that Y is the midpoint of VX. So that means we're going to be able to cut this 8.4 in half because Y is the midpoint. So this section here would be 4.2, and this would also be 4.2 to make up that 8.4. So now if we look at triangle VWY, what type of triangle would it have to be? Well, we've got 4.5 units for this side, 3.0 units for that side, and 4.2. So do we have any sides that are congruent? No, we don't. So it would have to be scalene because, and our reasoning is, there's no congruent sides. It's as simple as that for proving your answer. Okay. Next one, find the measures within this isosceles triangle with KLM with the base KL. Okay, so on this one here, we've got, you've got to remember that we've got the base is KL, so let's just make sure we know that. So the base here is KL, so that means that these are the legs, LM and KM would have to be the legs. So, and if you just remember about that, the legs have to be congruent in an isosceles triangle. Okay, because it's given that it's an isosceles triangle. So because they're congruent, we can set those legs equal to each other because we know that they have to be congruent. So 4D minus 13 equals 12 minus D, and I can go ahead and try to solve from there. So in order to do this, what I'm going to do is I'm going to add D to both sides. I'm also going to add 13 to both sides. There's multiple ways to do this, but I like dealing with the positives. So now I have 5D equals 25, and then when I divide, I'm going to get D equal to 5. Okay, and just do it by doing algebra. So now that I know that D is equal to 5, I can find all of these lengths by plugging 5 in. So I'm going to plug in this 5 here to this D, and I know that KL is then 5 plus 6, which is 11. I can find KM by plugging 5 in here and saying 4 times 5 is 20, minus 13 is 7. And I could plug it in here to LM, but I also already know that LM has to be 7 as well because it's congruent. And then I would have the measures of the triangle. So be careful what they're asking for. Are they asking for the measures of the sides, or are they asking for the variable D? Okay, sometimes they ask for both. So just make sure we're reading the question. All right? And one more I think you have on yours. Yeah. Use the distance formula to find the measures of the sides, RST, and classify it by its sides. So I'm going to let you guys work on that. The only tip I'm going to give you is you have the points. You're going to have to do the distance formula 3 times. You're going to have to do it for RS, You're going to have to do it for ST, and you're going to have to do it for RT. But once you get those distances, you'll be able to tell me if it's scalene, if it's equilateral, or if it's isosceles. And I suppose if you wanted to over here, you could use the Pythagorean theorem if you wanted to do it that way to find each distance. But it's kind of up to you. Okay? So that's it for these 4-1 notes on classifying triangles by their sides and by their angles. And finish these notes up, finish these examples, and bring your questions to class. Thanks a bunch. See you next time.